Greetings once again, my little triglets. Welcome back. Today we're going to talk about section 5.3, and it's all about trig functions of any angle. Okay, in the last section we did 30s, 60s, 45s, more special angles, but now we're going to talk about any angles. Trig functions are used to model situations where things happen again and again. The tide coming in and out, the rise and fall of the sun, your biorhythms, a lot of things like that. So we need to get past the right triangle trigonometry. We have to talk about other angles that are much bigger. So let's do a few little pictures here. Here's my first picture, and I'm going to draw an angle that goes right here. Now that angle can form a triangle, and it does make a right triangle. And we can label its sides x on the x-axis, y on the y-axis, and r for the radius. Now think of another triangle, or think of another angle. Let's say my angle goes from here to here. So it opens really wide. Think of a book opening most of the way. So that's my angle theta. Now I can't make a right triangle by connecting this way. There's no way to make a right triangle. So I'm going to make my right triangle in this quadrant instead. I still have x, y, and r, and basically we're going to use this triangle here to figure out this angle, because we can't make a right triangle on the right side, so we have to make it on the left. So once I move to the next quadrant too, let's take our angle all the way into this quadrant. So it's like you open that book, this and this are the book. You're opening it beyond flat. Okay, so my angle I'm dealing with is that one, but the triangle I have to use is this one, because it makes the right angle. So I have x, y, and r again. Let's draw the last one in the fourth quadrant. This time we're going to open that book all the way around till it's almost back to back. So here's our angle, but the triangle we're going to use is this one. So we have x, y, and r. So every triangle kind of looks the same, just depends on what quadrant you're in, if you know what direction you're going. All right, so they have given definitions, and we're going to look at this first triangle here. Okay, we're going to look at that one. Definitions for the sine of the angle, cosine, tangent, and then they're equal twins, cosecant, secant, and cotangent. So instead of opposite over hypotenuse, whoops, I want, looking at this one, if I have this as my angle, this is opposite and this is hypotenuse. That's y and r. So we're going to move away from opposite and hypotenuse, and we're going to use y and r because they're not always going to give us a picture. So we're not going to be able to see which one's opposite or hypotenuse, but they are going to give us the x, y, and r values. So for cosine, instead of y over r, it would be x over r. For tangent, opposite over adjacent would be y over x. Now for cosecant, secant, and cotangent, all we do is flip those over. So for sine, flipped over, I get r over y. For cosine, I flip that over, I get r over x. And for tangent, I'm going to flip that over and get x over y. So this is very important. Put a star in there. You need to memorize those and try to get away from opposite, adjacent, and hypotenuse. Now let's try a problem that involves some of that stuff. So let's say we have point P, and it is at -3, -5, and that's a point on the terminal side of theta. So I want to find the 6 trig functions. All right, so let's draw a circle here. Now we're just going to estimate approximately where -3, -5 is, and we're going to try to make it land right on the edge of the circle. So there it is. It's in the third quadrant. If I continue to finish my triangle, it's going to look like that. Now the angle that they're talking about, this theta over here, is really from here to here. It's that big angle, but we're using the small triangle to help us find that. All right, so if I label this -3, -5, that tells me that x is -3 and y is -5. So I'm going to write that down. X is -3, y is -5. And how, on a right triangle, if I put those labels in, -3 and -5, in a right triangle, we know we can use Pythagorean identity to find the hypotenuse. So to find r, I'm going to do -3 squared plus -5 squared equals r squared. 9 plus 25, that's 34. So r squared is 34. So r is the square root of 34. Okay, our work is almost done here. So now I'm going to do sine, cosine, tangent, and then their evil twins are cosecant, secant, and cotangent. All right, we said sine, if I go back up to a previous page, sine is y over r right here. So y over r, in our case, is -5 over root 34. Now you got to get the radical out of the bottom. So that's going to become -5 root 34 over 34. So I'm going to get rid of that, -5 root 34 over 34. All right, then cosine. Tell you what I'm going to do. I'm going to erase those so I have more room here. Cosine is x over r. So this is y over r, this is x over r. So that's -3 over root 34, which would be root 34, -3 root 34 over 34. Tangent is y over x. Let's put it over here, y over x. Erase. Whoa. It's a little bit big. So that would be, y over x would be -5 over -3, which is 5/3. Okay, so now we have to flip them all over. So cosecant flipped over. Now originally it was -5 over root 34, so I'm going to use that, root 34 over -5. Secant, I still have that one listed here, so I'm going to put that as root 34 over -3. Now your negative sign can go on the top or just in front, doesn't matter. And then tangents, evil twin is cotangent, flip over 5/3 and I get 3/5. Okay. All right, so that is anywhere. I don't know what that angle is. It's not one of our special angles, but we do know the ratio of its sides, so we can do all that. Now let's look at the corners. Now I know circles don't really have corners, but the corners are these positions. At least I call them corners. Now if I try to draw a triangle there, I can't really. There is no up and down. There's no y value to make it go up to form that triangle. So at the corners, we can't make a triangle. But we can get some other ideas out. So in this case right here, this point, I know that the y value is 0 because I'm not going up or down. The x value happens to be the same as the radius of the circle. So x equals r, so that means x over r would have to be 1, because if they're the same, it's like saying 6 over 6 or 2 over 2. And y over r would be 0 over r, which anything with a 0 on top is just going to be 0. So this point right here is going to have the label, the x value is 1, the y value is 0. So all the corners are going to be 1s and 0s. Now this one doesn't have an x motion, it doesn't go right or left, so that's the 0, and the y will be the 1, because the y and the radius are the same. Over here, can you guess what that'll be and what this will be? Because we're going to be going left, that makes the x negative, and the y stays at 0, and because we're going down, the x is still 0, but the y is negative. Okay, so it all depends on what direction you're moving as to what those are. All right, so let's take 180 degrees, and let's find the sine, cosine, tangent, then cosecant, secant, cotangent. So sine is just y over r. So the y at 180, this is 180 or pi, but the sine is 0 and r we don't know. So 0 over r is still 0. So the sine is 0. Cosine, actually it's already listed here. We can just say it's -1. Tangent is sine over cosine. We talked about that before. So if I take the sine answer, which is 0, over the cosine answer, which is -1, I get just plain 0. All right, now flipping them over. So I need to write the reciprocal. I'm going to put 1 over, 1 over, 1 over. So the reciprocal of sine is 1 over 0. Now we know we can't divide by 0, so that answer is undefined. It is not graphable. We can't do it. If you try to divide by 0, the world blows up, so please don't try to divide by 0. Because I kind of like my life, and I'm thinking you do too. Now secant is 1 over the cosine. Cosine's -1, so its answer is -1. And cotangent is 1 over 0 for tangent, and that would be another undefined. Now if you notice, there are 2 zeros, there are 2 undefines, and there are 2 -1s. That's how it's always going to come out. You're going to have 2 of each. So that's a good check to decide if you did it right or not. All right, last little thing. We are going to use a smaller angle, just like we did using that smaller triangle on those big angles. They call it a reference angle. But it seems like when I call it that, kids get confused. So I'm going to just call it the smaller angle to find a large angle. So for example, if I have right here 150 degrees, which in radians is 5 pi over 6, I want to find the sine of 5 pi over 6. Well, if I drew that triangle there, this angle is only 30 degrees. So we can actually think of our 30-degree angle or triangle as we find that. So think of this as 30. The 30 ratio is 1 to 2 to root 3. So if I'm trying to find the sine of 5 pi over 6, that's like sine, remember, is y over r. So this is my y value, it goes up and down, and this is my r value. This would be my x because it goes side to side. So this would be root 3, 2, and 1. So sine is y over r, which would be 1 over 2. So the sine of 5 pi over 6 is 1/2, just like the sine of 30 is 1/2. Let's try the cosine of 5 pi over 6. Cosine is x over r, so in our case it's square root of 3 over 2. Now the big difference here, the thing you have to be careful with is because I'm going to the left, this technically is a minus, it's a -3. Because on the circle there are directions. There's positive and negative directions. So if I'm not in the first quadrant, I might have to change the sign of some of these. So I have to make sure that I make this a -3, root 3 over 2. Okay, because it's in quadrant number 2. So in class tomorrow, we're going to talk more about this. Okay, but for right now, just remember, Trig loves you, so love Trig back. Ta-ta.